All right, let's go ahead and talk about trig identities. So we've actually kind of done something a little bit like this on the very first lesson, the very end of the first lesson, but we're going to go ahead and do a little bit more. So we are actually going to use the information given to us to find the other major trig ratios, so sine, cosine, tangent. So we already have sine, so in this case we're going to figure out what the exact cosine and exact tangent ratios would be. In order for us to be able to do that, we're actually going to have to go back to basic SOHCAHTOA math, right triangle math, and you're going to have to draw a right triangle. So here's the deal. We're dealing with sine. So, in fact, this might be good to know. The general idea with sine is our y values, right? So y's are negative in the third and fourth quadrant, but then positive in the first and second quadrant. Cosine deals with your x's, and cosine is positive in the first and fourth quadrant, but negative in the second and third quadrant. And then tangent is your y over your x. Okay, so in this case, that means it's positive in the first quadrant and positive in the third quadrant, because in the third, both the x and the y are negative, but then in the others, it's going to be negative. So that's really, really important to know so that we can pick the right quadrant. And I probably should move these over because they're now in my way. So we currently have a scenario where sine is negative. So we've got a negative sine, and this is saying tangent of theta is bigger than 0, so it's a positive tangent. So negative sine means it has to be one of these two quadrants. A positive tangent tells us it has to be either the one or third. So the only place where both of those match up is in the third quadrant. Okay, so we know based on that information we're in the third quadrant. And I'm going to go ahead and draw my triangle in the third quadrant. So sine is opposite over hypotenuse, so the opposite side will be -5. The hypotenuse is 9. And then I'm going to use Pythagorean theorem to figure out this last side. Since we've got the hypotenuse, it's going to be 9 squared, and I'm going to go ahead and subtract the -5 squared from that to find our missing side. So 9 squared minus 5 squared is 56, and the square root of 56, so I should say x is equal to, positive or negative square root of 56, which, since we're in the third quadrant, we're going to use the negative square root of 56, which is -2 square root of 14. So the x's have to be negative. So from there, I'm going to go ahead and find my cosine value and my tangent value. Let me space those out better though. So cosine will be our adjacent, so -2 square root of 14 over our hypotenuse. And you'd be done with that one. Tangent will be our opposite, so -5 over our adjacent, so -2 square root of 14. So the negatives cancel out, and you end up with 5 square root of 14, because I'm going to rationalize it. I should write that out. Over, and then the square root of 14 times square root of 14 is 14, so this is just 2 times 14 on the bottom, or 28. So that's our tangent. Let's go ahead and do another one of those. And let me pull these over, since that was kind of helpful. So, maybe it won't let me. That's okay. We don't need it. Okay, so this time our cosine is positive, but our sine is negative. So I'm just going to come back to this. So if we have a positive sine, or sorry, positive cosine, right? Yeah, positive cosine. It's going to be one of these two. But we have a negative sine. So the place where it matches up is in the fourth quadrant for these. So quadrant 4. So I'm going to draw a right triangle in quadrant 4. Notice my the angle's always coming from the origin, and the angle's always formed by the positive x-axis, or the x-axis I should say. So cosine is our adjacent over hypotenuse, so adjacent is 2, hypotenuse is 3. And then I'm going to go ahead and use my Pythagorean theorem. So 3 squared minus 2 squared is going to equal our y squared. And that's 9 minus 4, or this, so y squared equals 5. So y equals plus or minus square root of 5. Since we're going down below the x-axis, we're going to use the negative. And then we can go ahead and work our magic. So sine of theta is going to be our opposite, so negative square root of 5 over our hypotenuse, so 5. Or sorry, 3. I wrote the right number. Tangent is going to be our opposite, so negative square root of 5 over our adjacent, so 2. And there was nothing we had to do to simplify either one of those. Sweet, okay. I thought there was just one more of these. Okay, let's do one more. This time I give you a tangent. And I actually very clearly tell you what quadrant. Right here, it's saying it's between 0 and pi halves. So 0 and pi halves would be first quadrant. It's quadrant 1. So that's an easy one to draw. Tangent is opposite over adjacent. So opposite is 6, adjacent is 5. And then our hypotenuse is going to be 6 squared plus 5 squared, and we'll take the square root of that. So 6 squared plus 5 squared is 61, and the square root of 61 does not simplify. So h equals the square root of 61. Now notice hypotenuse is always positive, so I didn't even worry about the plus or minus this time. Plus we're in the first quadrant, everything has to be positive. So we just need to find our cosine value. So our cosine would be our adjacent, so 5, over our hypotenuse, so square root of 61, which we would rationalize, and we would get 5 square root of 61 over 61. And then we'd go ahead and do sine, same idea, except we're doing opposite over hypotenuse. So we have square root of 61 over square root of 61 that we multiply by, and that gives us 6 square root of 61 over 61. And we've done.